Hey, what's going on, guys? So, got another Leetcode question here for you today. 1926, nearest exit from entrance in maze. I've already solved this, so hopefully I can write code here a bit faster to save y'all some time. We're gonna go ahead and get started here. So, here's the problem. We're given a matrix, zero indexed, with empty cells represented as dots, walls are pluses, and you're given the entrance of the maze as a vector, row and column. In one step, you can move up, down, left, or right. You cannot step into a cell with a wall. You cannot step outside the maze. Goal is to find the nearest exit. An exit is defined as an empty cell, which is a dot, that is at the border of the maze. Entrance does not count as an exit. Return the number of steps in the shortest path from the entrance to the nearest exit. So first thing we're going to note is that anytime we see things like this, we're in a maze, instantly think graph. Anytime you see the word nearest and maze together, think breadth first search. Maze, grid, city, start thinking breadth first search. So we know we're going to need a queue, so let's go ahead and put a queue on. I'm going to create a queue of rows and columns. So I'm going to represent it as a pair of int, q. Q. And our basic template for breadth first search is going to be like while q not empty. And we're going to find our exit condition, find exit, return distance, else we're going to return -1 at the bottom. This is just a really basic template here. So now we're gonna have to find, we're gonna say find all, Alright guys, so I just went ahead and wrote a little more code. So just to review, we have our queue. I'm putting on the starting position, entrance 0, entrance 1, and then I'm marking it with an and symbol. I'm gonna use the and symbol to represent an empty cell that we've already quote visited, and visited I'm just saying means it's been placed on the queue, not necessarily popped off the queue for processing yet. And then I'm just defining the m and n variables. M will be maze.size, represent the number of rows, and n will represent the number of columns. And I'm going to use this distance variable to keep track of how far we've traversed using our breadth first search. Okay, so now we put our starting position on the queue. So we're going to go ahead and do some processing with it. So say int size is equal to q.size. And then we say while size minus. So now everything I process inside of this while loop is going to be distance away from the entrance, I guess. So distance 0 will be at the entrance, the distance 1 will be at all cells that are one distance away from the starting position. So then I'm going to assume everything that comes off my queue is a valid empty cell and not a wall. So I'll check for walls when I put them on the queue. Okay? So I'm going to say auto cell is equal to q.front, q.top. Also if cell.first, I want to check if it is an exit. It's an exit if it's empty cell and at one of the boundaries, and that is not the entrance. So cell.first is equal to, I'm just gonna do this instead of typing this out. Cell.first y is equal to cell.second. Make my life easier. X is equal to 0, or if x is equal to n minus 1. Okay, so that'll mean it's at the top or the bottom of the maze, which would be an exit. Or if y is equal to 0 to the left column, or y is equal to n minus 1. So now we're at the boundary of our maze, and we also need to check if it's an empty cell. This is one condition. That's one condition. condition, set the boundary, and it needs to not be my entrance position. Does not equal y does not equal, so it's not the same starting position. It's not the starting position. Then in that case, I can just return. Oh, I don't like this being here. Hold on. I don't like that. Distance. Okay. Now, okay. Now we're gonna visit neighbors. So let's say vector, vector, event. I'm just gonna call it dirs. I'll show you what it is. Dirs is gonna be directions we can go from our current cell. So we're gonna go 1 0, -1 0, 0 1, or 0 -1. So for x, this is moving down, this is moving up, 0 1 is moving to the right, 0 -1 is moving to the left. So we'll say for auto d inside of dirs. I already used x and y here, so I'll say new x is equal to x plus d dot first. Sorry, d is 0. Yeah, okay. So int new y is equal to y plus d at 1. Bam. Now let's say if check conditions. If new x is equal, it's out of bounds. So, or let's just check if it's within bounds. So if it's greater than or equal to 0, and if new x is less than m, and new y is greater than or equal to 0, and new y is less than n. And what's it called? Maze at new x, new y is equal to a dot. Empty cell we can visit within bounds. We're going to say maze at this is equal to, mark it as visited so we can't put it on again, and then we'll say q dot in place new x, new y, and that's it. Now, okay, I just found the issue in my code. So I was walking through this example over here, this example, which is example 1. And what I discovered was that things are fine. I'm visiting the neighbors, things are fine. It's my exit condition that's the problem. So it's this line here. So I'm saying if x is not equal to entrance at 0 and y is not equal to entrance at 1. So the problem is that if I go up, the x coordinate is different, but the y coordinate is the same. So this condition will fail, and we won't return, but it shouldn't fail. What I need to say is just, I just need one of these to be different for a valid exit condition. Because if just one of them's different, then it's not the same position that it started at. Okay, so I'm gonna go ahead and run this now. And that's okay. So now all my test cases pass. Comment out this debug line. And at this point, I'm gonna go ahead and submit. It passes. Great. Okay. Yeah, so that was a tricky part for me, I guess, was just this exit condition. Making sure I had this exit condition right. So I just check if I'm at the boundary, if I'm at the top, or I'm at the bottom, or I'm at the left, or I'm at the right. And then I said if x is not equal entrance at 0, or y is not equal entrance at 1. And that was it. Hope this code is pretty straightforward. We can walk through it again. So I have a queue, and we can do our time and space complexity here also. M for maze.size, which is the number of rows, and n, maze at 0.size, which we know is valid, given in the problem description. M and n are at least 1, and somewhere between 1 and 100, so I can do m at 0. Made a direction array since we can move up, down, left, or right. I found that in these breadth first search questions, where you're trying to find a distance from a location, what I used to do was define a struct, something like this, and inside the struct, I would have and then I would keep track of the distance in the cell and put these kind of things in the cell. So it's like row, column, and then like do distance plus 1 from the current location. And I found that I just don't need to do that. I can just use the properties of breadth first search, and that each time I iterate through the queue is going to be 1 distance further than the previous iteration. And I'm going to call an iteration like this thing, like a level. So anyways, so I'm going to say distance at 0, distance is 0. I'm going to put on the starting position. So in the worst case scenario, we're doing breadth first search. So we could put up to, it sounds like n or n divided by 2. I'm going to say, and I'm modifying the maze. So, yeah, so I'm using O of m times n space. For time, I could visit each cell up to once. Also consider 4 directions within the cell, which would be 4 times the number of cells. But this loop will only go through the total number of cells in the maze, because I will not put things on the queue twice. So it'll be each cell times 4 for 4 directions. So time will be big O of 4 times n, which is just equal to big O of n times n. Okay, let me see here. That's what the solution says. Haha. Use a queue, first in, first out, entrance. That is okay, and it's distance 0 to queue and mark entrance as visited. Okay, how did they do it? Yeah, they just marked it as a wall. That's what I could have. Yeah, I was thinking that, because I realized I'm not using this for anything. I'm just checking if it's an empty cell. Anyways, array of 3. Why is it 3? Start BFS from the entrance. Use a queue to store all the cells to be visited. Is this storing the distance? Let's see. So queue.push. Current distance plus 1. Okay, so they're doing the same thing that I've done in the past. Okay, cool. Okay, time complexity is m times n. Let's see what they say. For each visited cell, we add it to the queue and pop it from the queue once, which makes constant time, as the operation on queue requires O1 time, which takes constant time. For each cell in the queue, we mark it as visited in maze and check if it has any unvisited neighbors in all 4 directions. This also takes constant time. Yeah, 4. In the worst case scenario, we may have to visit m times n cells before the iteration stops. Yes. Space complexity. Okay, this kind of confused me. Space complexity is max of m times n. We modify the input matrix maze in place to mark each visited cell. It requires constant space. Constant meaning the size of the maze? I mean, what? Are they just not considering it a space? Modifying maze? Modify yeah, see that's, I don't know. I feel like when you modify things in place you're still using space, but use a queue to store the cells to be visited. The worst case scenario, there may be m plus n. Okay, so this is, I guess this is correct. M plus n cells stored in the queue. I don't understand this max of m plus n though. So wouldn't it would just be m plus n then? Or oh, well, I guess. I think this makes more sense. O of m plus n. All right, well, that's about it. Thanks for watching. Please comment, like, and we'll do another Leetcode here in the very near future.